Now we're going to do the derivative of f of x equals a to the x for any real number a greater than 0. So we start off with the limit definition of the derivative again, which is right here, limit definition. We again factor out the a to the x, just as we did with the derivation of the derivative for e to the x. Let's factor this out. Again, the a to the x is just a constant when you view it that x is a specific value. The h is what's moving down to 0, not the x. So you can factor out the a to the x as a constant and get the limit resulting of a to the h minus 1 divided by h. Now let's just work on that. We do a little trick of the trade. We say that we take this a and we change it into equivalent form, which is e to the natural log of a. E to the natural log of a. E and natural log are inverses of each other, so they undo each other and you just get a back. So e to the natural log of a equals a. By the way, natural log of a is log base e of a. And so when you see it that way, you see that these work out the same. A is equal to e to the natural log of a. Then we multiply the exponent n. That's just algebra. Then we do a maneuver, a trick of the trade. We let t equal log a times h. As h goes down to 0, so does t, because t is just a constant times h. And note that h, if you solve for it, is t divided by natural log of a. So then we substitute in. So we have our limit here then is equal to e to the t, because this log ah is the t, and as h goes down to 0, so does t, goes down to 0. Then in the bottom we have this h, and of course h is t divided by log a. So we substitute over. We work on this limit now. We take this fraction, multiply it using algebra, log base a, top and bottom, cancels off the bottom, and you get the log base a here. That's just algebra. Then we realize this looks familiar. We take the log a out because log a is just a constant. We have this limit here, and that limit we've already investigated in a previous video was equal to 1. That's just 1 right here. Therefore, our final statement is the derivative of f of x equal a to the x is the limit definition here, which comes out to be a to the x times log a, because it was over here a to the x times this part here, and that part was log a. So here's your derivative. We usually write the log a statement first. Log a times a to the x. Now notice, if A, a special case, happens to be e, then log a times a to the x is log e to the x, and the natural log of e is 1. So you do get e to the x like you're supposed to. So the formula works. So know this for a test, this entire derivation.